Hello, this is Mrs. Ward, and I'm going to go over the 3.2, which the quiz actually says 3.1 to 3.2 review, and this is a review worksheet that I gave you. So the first one, it says evaluate the limit. First thing we're going to do is we're going to try and do direct substitution. When I do that, I'm going to have 2 over negative 3 plus 3, which would be 2 over 0. That is undefined, so at that point, and it's not that special case where I have 0 over 0, so the next thing I'm going to do is pick up my calculator and I'm going to graph. I know it's going to be undefined at negative 3, but I'm going to try like negative 3.01, negative 3.1, negative 2.99, negative 2.9. And when I do that, here I got negative 200, here I get negative 20, here I get 200, and here I get 20. Since I'm not approaching the same number from both sides, I'm going to say the limit does not exist. And I actually have to write the number, or how about I say that it approaches two different numbers. Two different numbers. Okay, the next one, I'm going to do the same thing, and there's a negative 2, and then I'm going to make 2 squared minus 4, so I'm going to get negative 2 over 4 minus 4, so I get negative 2 over 0. Again, pick up my graph, look at it, looks kind of funky, so I am going to do that chart, and I'm going to do 2.01, 2.1, 1.99, 1.9, and when I put that in my calculator here, I got like a negative 5.728. This was a negative 50.13, I think. This is undefined. This is 49.88. I'm trying to read my writing. This is 4.78. Again, not approaching the same number, so I'm going to say the limit does not exist. And my reasoning is the same as it was here. It's approaching two different numbers. The next one, I'm going to do direct substitution, put in 0. So I'm going to have 0 plus the absolute value is 0, which will be 0 plus 0, which is 0. So this limit is just 0. When I do number 4, when I look at the graph, I see that I have two straight lines, but they're not approaching the same number, and that's not the same number 4 you have. Funky. You have 4x over the absolute value of negative x. So, and you're taking the limit as x approaches 0. Don't know why that was different. So I am going to put 0 in my table, and I'm going to do negative 0.01, negative 0.1, and then 0.01, and then 0.1, and this is undefined. And when I do that, I get 4 here, 4 here, negative 4 here, negative 4 here. So this limit does not exist, and your reasoning is because it's approaching two different numbers. Number 5, I am putting in 0. 0 is where I have that break in the graph, so I'm going to put into 0 into both. So the first one, since y is equal to 2, it doesn't matter what x is equal, so the first side will be 2. Next one, when I put in 0, I'm going to have 0 squared plus 2 times 0 plus 2. So this is from the left, this is from the left, this is from the right, and both sides is going to approach 2. Since it is approaching the same number, then my limit as x approaches 0 of f of x is going to be 2. If it approaches two different numbers, it's not going to be the same. So now I'm doing number 8. No, I'm not. I'm doing number 6. I had the break at 3. I'm taking the limit as x approaches negative 3, so I'm going to have 2 times negative 3 plus 4. So that's negative 6. That's not the same one. Yes, it is. Negative 6, so I'm going to have negative 6, so this will be negative 2. And then the other one is also negative 2. So again, since they are the same, I'm going to say the limit as x approaches negative 3 of f of x is going to equal negative 2. Apparently, I have two different worksheets, so I'm just going to put that one away. All right, the next one, I'm taking the limit as x approaches 0, so this is negative cubed root. Again, direct substitution is your first means of resource. So this will be a negative cubed root of 5. That is a number. That's some type of decimal. I have no idea what it is. But that is going to be my limit. The next one I'm putting in -1, so I'm going to have the opposite of -1 squared over 2 plus -1 plus 5 halves. So this will be 1, but negative, so this will be -1/2. And then I'm going to write this -1 as a -2 over 2 plus 5 halves. And when I do that, that's -3, so I get 2 over 2, which is 1. It's equal to a number, and so it's going to be 1. If you can do direct substitution, whatever you get is your answer. The next one, number 9, I'm taking the opposite of the cubed root of 2 times -2 minus 4. So I'm taking the opposite of the cubed root of -4 minus 4. So I'm taking the opposite of the cubed root of -8. The cubed root of -8, remember you can take an odd root of a negative number, whoopsie, and that is just going to be -2, because -2 times -2 times -2 is that -8. And when I take the opposite, I'm going to get 2, and that is my limit. Number 10, doing direct substitution, I'm going to have 3 to the third minus 4 times 3 squared plus 6. So this is 27 minus 36 plus 6. So I'm going to get -3. So my limit is -3. I did not put any trig functions on the quiz, so you don't have to worry about that. So number 11, I am going to do the square root of 9 minus 3 over 9 minus 9. The square root of 9 is 3, so this will be 3 minus 3, so I'm going to have 0 over 0. That is undefined. That is a special case because of that 3 over 3. So since I have that radical, I'm going to choose the method where I rationalize. So I'm going to write this as the square root of x minus 3 over x minus 9. And I'm going to multiply both the numerator and the denominator by the square. So I said the square root of x plus 3, square root of x plus 3. When I multiply the numerator, I am going to get x minus 9. And then my denominator is going to be the x minus 9 times the square root of x plus 3. These x minus 9s will simplify, and I'm going to have 1 over the square root of x plus 3. Remember, we're taking the limit as x approaches 9, so I'm going to substitute 9 in for that x. So my final answer is going to be 1/6. Okay, number 12. I try and do it, and when I put 0 in here, that's undefined. I do realize that I do have a fraction within a fraction, so I'm going to try and multiply by my least common multiple. The least common multiple is just going to be that 1 plus x because that is my only denominator. So I'm going to multiply by 1 plus x over 1 plus x, and I'm multiplying that by x over 1 over x plus 1 minus 1. Here, when I multiply, when I take this times this, my numerator, I'm just going to write it as x times 1 plus x. Here, when I multiply, now I'm going to multiply it by this first. Here, the x plus 1s will simplify, and I will have a 1 minus, because that's that minus sign. And then when I multiply that negative sign by 1 plus x, because remember I have to distribute it to that term as well. So when I do that, I'm going to have x times 1 plus x over 1 minus x. So the 1 minus 1, that will be 0, and then x will go into x1, x will go into this -1. So I'm going to end up with a negative times 1 plus x, and I'm trying to take the limit as x approaches 0. So -1 plus 0, so that's going to be -1. So my final limit is going to be a -1. The next one, when I go to substitute in -2, I'm going to have -2 squared minus 4 all over x plus 2, or -2 plus 2. I get 0 over 0. So here's that negative sign that's just sort of hanging out. I'm going to factor x squared minus 4 as x plus 2, x minus 2. And I'm going to make this x plus 2. Here the x plus 2's will simplify. I'm left with negative times x minus 2. I'm taking the limit as x approaches -2. So I'm going to have negative, then this will be negative 2 minus 2. So this will be the opposite of negative 4, and my limit is going to be 4. Okay, the next one, when I put in 1, I'm going to have 1 minus 1 over the square root of 1 plus 8 minus 3. So this would be the square root of 9, which is 3. So I'm going to end up with 0 over 0. So I am going to rationalize because of that radical. So I'm going to take that x minus 1 over the square root of x plus 8 minus 3. And I'm going to multiply by the conjugate. So the square root of x plus 8 plus 3. Multiplying both the numerator and the denominator by that. So when I multiply the numerator, I multiply this times this, I'm just going to leave this as x minus 1 times the quantity of the square root of x plus 8 plus 3. And then in the denominator, the square root of x plus 8 times the square root of x plus 8 will just be x plus 8 minus 9, because that's what negative 3 times 3 is. So I'm going to have the quantity of x minus 1 times the quantity of x plus 8 plus 3. And then when I simplify that, that's going to be x minus 1. Now those x minus 1s will be simplified. I'm left with the square root of x plus 8 plus 3. And I'm taking the limits as x approaches 1. So I'm substituting in 1. So 1 plus 8 plus 3. So this is the square root of 9 plus 3. So 3 plus 3. And my final answer is 6. Okay, these ones are on the review worksheet, but I did not put them on the quiz. They'll be on the test, so we'll just go over them now. I just want to remind you that when I take like a plus b and I square it and I FOIL it, I get a squared plus 2ab plus b squared. So I'm going to use that pattern when I go ahead and FOIL this. So I'm going to take the limit as h approaches 0, and then 1/2 squared is going to be 1/4. Plus, when I multiply 1/2 times h, it's 1/2 h. I'm going to take 2 times that, so that's just going to be h plus h squared minus, and then 1/2 squared is 1/4 all over h. Now I can see that the positive h and the negative h, positive 1/4 and negative 1/4 will be 0. So still taking the limit as h approaches 0, and I'm going to have h plus h squared over h. Cannot simplify this h until I factor it out for the numerator. So I'm going to factor it out and make it 1 plus h all over h. Now that I've made it a factor, I can simplify it. And I'm left with 1 plus h. And I'm taking the limit as h approaches 0. And now I'm going to put 0 in for this h, and my final answer is just going to be 1. Okay, doing the next one, same idea, except for now I'm raising to the third power. When I raise something to the third power, that's going to be a to the third plus 3a squared b plus 3b squared b plus b cubed. You learned that in Algebra 2, but I'm sure you don't remember it, so there it is. So that's what I'm going to do. So changing colors real quick. I'm going to bring the work down here. So I'm going to have 1/2 raised to the third power, which will be 1/2 raised to the third power, plus 3, then 1/2 squared times h, plus 3 times 1/2 times h squared, plus h to the third, minus 1/2 raised to the third. And this is all over h. I'm taking the limit as h approaches 0. I don't even have to figure out what 1/2 to the third power is, because that will equal 0. Everything that I have left has an h in it, so I am going to simplify the 1/2 and factor out the h at the same time. H approaches 0, so this will be h times, and then 1/2 squared is 1/4, so this will be 3/4. That 1h is gone, plus 3 times 1/2 will be 3/2 h plus h squared. And this is all over h. Now the h's can simplify, and I'm left with, as I take the limit, as h approaches 0, of 3/4 plus 3/2 times 0 plus 0 squared. And so my final answer is going to be 3/4. Okay, the last one is rationalizing. So these ones I'm going to rationalize. If I put in 1, I'm going to get 0 over 0 because I'll have the square root of 4, which is 2. 2 minus 2 is 0. So I am going to rationalize. So I have the square root of x plus 3 minus 2 over x minus 1. I'm going to multiply by the conjugate. So the square root of x plus 3 plus 2, square root of x plus 3 plus 2. And so when I multiply the numerators, this times this will just be x plus 3. And then the middle term goes away, and negative 2 times positive 2 will be 4. All over this quantity, x minus 1 times the square root of x plus 3 plus 2. Now, when I combine my like terms in the numerator, that's going to be x minus 1 over x minus 1 times the square root of x plus 3 plus 2. Here, the x minus 1s will simplify, and I'm left with 1 over the square root of x plus 3 plus 2. And this whole time, I've been taking the limit as x approaches 1. So when I put in 1 here, the square root of 1 plus 3 plus 2, that is going to be 4. The square root of 4 is 2, so I'm going to have 2 plus 2, and my final answer is going to be 1/4. Moving on to the next one, same thing. If I put in 4, I'm going to have 2 minus 2 over 4 minus 4, and I'm going to have 0 over 0, which tells me I can simplify. Square root of x minus 2, x minus 4, multiplying by the conjugate, square root of x plus 2, square root of x plus 2. When I multiply the numerator, I'm going to get x minus, and 2 times 2 will be 4. So x minus 4, that middle term goes away. That's why you multiply by the conjugate. And then I'm going to have x minus 4 times the square root of x plus 2. So now these parentheses will simplify. I'm left with 1 over the square root of x plus 2, and I'm taking the limit as x approaches 4. So I'm substituting in that 4 for the x, and the square root of 4 is 2. So my final answer is going to, again, be 1/4. Okay, this one I'm looking at a graph. I did my best. I'm thinking the copy's pretty bad, though. But here I'm taking the limit as x approaches 3. So I'm going to highlight the line at 3. 1, 2, 3. So here's 3. Oh, that's a really bad line. So it wants to know the limit as x approaches 3. Well, I can see that from the left it's approaching 6. From the right it's approaching negative 5. Since it's not approaching the same number, I'm going to say it does not exist. The next one is the limit as x approaches 0. So we'll highlight that a different color. Here's 0. As I approach from the left, it's 5. As I approach from the right, it's also 5. So I'm going to go ahead and say that limit does exist, and it is 5. The limit as x approaches negative 2, here is negative 2. As I approach from the left, it looks like it's 4. As I approach from the right, it looks like it's negative 1. So I'm going to say it does not exist. And then this one, the limit of f of x as x approaches 1. So I can highlight 1. I think I can highlight 1. What color have we not used? We have not used this lovely pink. 1. Well, here, oh, that's bad highlighting. Here, it's right about here, because from the left and from the right. So I'm going to go ahead and estimate that that's about 5.5 or 5.5. And then the last one wants f of negative 2. Well, that's this green line here, and that's going to be this solid dot, which is going to be negative 5. All right, that's the review worksheet. I hope that helps, and I'll see you next time.